Okay, so if you want to know what a conic section is, we need to define it. And a conic section is, and this is kind of a rough definition, the set of all points, I'm sorry, an ellipse is the set of all points whose distances from 2 points, we'll call those points foci, sum to a constant. Let's see if you guys got that. Well, we'll talk about what it means. You guys got it? Oh, need 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Whoa! If I put a point in the center, and I have a string, and I connect it right here, okay? And actually, we're going to make the string into a loop, okay? The string is going to look like that. And I put this part right here, right on the point, and I put my marker right there, and I stretch it out as far as it goes. And I try to cover all the points of the same distance. What shape will it make? Yeah, if I, pull this thing tight so that it's, has a distance, say like this, and I go all the way around, I'm going to get, well, that's not very good, but I'm going to get a circle, right? Okay. Now, let's change it up a little bit. Let's take that loopy thing, that string, okay, and instead of putting it around 1 point, let's put it around 2 points, okay? And here's what's going to happen. It's going to stretch to about here, from this side. It'll stretch about here on this side. But what will happen is in between, the string as it loops around will make that kind of shape, right? And what will happen is it will kind of stretch it out into an ellipse. So an ellipse is just, instead of having one central point, you have 2 central points. This distance right here, let's call this distance, say, A, and this distance B. That stays constant the whole time if you were to add up those distances. So it's kind of a difficult thing to do, but actually I had Sarah Savicool today right here on the board. I put my 2 fingers on the focus points, and we got a string, and she did that, and she came up with this shape. Pretty bad, isn't it? Okay, she did a pretty good job. Better than mine on the board. But this is what we got, and we call those 2 points the focus points. So that's really the definition. So now you know how it's generated. So you really have 2 ways. You could slice a cone, or you could put 2 points and generate them. And we have to know all of those pieces. Now, we're going to write a lot of stuff down. It's going to sound really confusing right away, but it's not. You're going to get this information on your test. You just have to know how to use it properly. And, yeah. Here's an equation. X squared over a squared plus y squared over b squared is equal to 1. That's the general equation for an ellipse. And in this case, it's going to be a horizontal ellipse. It's going to be stretched horizontally. And the reason why it's stretched horizontally is you can see that a sits underneath x squared. So a is the biggest number, and it sits underneath the part that's stretched. We say a is greater than b, which is greater than 0. Now that's going to be stretched horizontally. We could stretch it vertically. In order to stretch it vertically, we put the largest number underneath y squared. So we have x squared plus b squared, or I'm sorry, x squared over b squared plus y squared over a squared is equal to 1. Again, a is greater than b, which is greater than 0. So that will stretch it vertically. You can see from the shapes right here, that's going to stretch it like that. That's going to stretch it like that. Where are these centered? Where's the center of these pieces? If you were to like the exact middle, what would you say? 0, 0. So all of these are centered at 0, 0. Like this equation centered at 0, 0. This equation centered at 0, 0. I'll show you what an equation looks like that's not centered at 0, 0, because we're going to try to do those tomorrow. X minus 3, you don't have to write this down. Where do you think that one's centered? 3, negative 2. Yep. Centered at 3, negative 2. So it's identical to this ellipse right here. It's just every point is shifted 3, negative 2 units. That's it. So we'll learn how to do that later. But right now, let's keep it easy. Let's center everything at 0, 0, and let's go from there. Okay. The first thing we like to talk about are the vertices. And the vertices are the endpoints of the direction that it is stretched. And the way that we find the endpoints is we take the square root of a squared. What's the square root of a squared? A. And so this is going to have a coordinate, negative a, 0, and positive a, 0. So if you were actually to list those coordinates for it right here for vertices, you would say plus or minus a, 0, and for here, it's actually 0 and plus or minus a, because you can see that it's stretched vertically. We would say that that is 0a, and this is 0, negative a. So they're almost the same. They just switch values in terms of x and y and stuff like that. Any questions about the vertices? Okay. Then we talk about the major axis. The major axis is the length, the farthest length between any 2 points on the ellipse. What is the distance between this point and this point right here? What's this length right here? A. What's this length here? A, and a plus a is 2a. Major axis has a length of 2a. You can tell in this case it's horizontal. What's the length of the one to the right? Is it the same or is it different? A and A, you make 2a. Instead of stretched horizontal, it's stretched vertical. So that's the only difference. What do you think the minor axis is? Yeah, that's the shortest distance between, the 2 points across from each other. So that would be this one and this one. Instead of having A used as coordinates, anybody want to guess what we have? B. You're so smart. So we have 0 and B, and we have 0 and negative B. Beautiful. So the minor axis has a length of what? 2b, and here it's vertical, whereas here we have coordinates of negative b, 0, and 0b. Whoop, I'm sorry, b0. Lots of a's and b's. Horizontal. So once we can find those points, then it's really easy to draw. You don't actually have to have the foci in order to draw it on a graph, but they are important. We need to find them. And we use another variable to represent the foci. Anybody want to guess what we use? C. It's almost like we're the same people. You're just saying what's on my mind. You guys seen those commercials where the... Never mind. Okay. You know, the guy, he's wearing one of the NFL players' jerseys. It's like, oh, it's almost like we're the same. Who would that benefit if we were more like each other? Would that benefit you or would that benefit me? Okay, so maybe be kind of a trade-off. You might be better at math, but you might have less of a social life if you're more like me. Is that... It's funny. One time I had students, they wanted to get together. They said, hey, let's hang out this meet us at 4:30 a.m. at the mall. So I showed up 4:30 a.m. at the mall. There's nobody there. I thought it was kind of early, but I was just like, well, maybe they want to get a head start on the day. No, I'm not. Come on, Trenton. So your foci will be plus or minus C 0, and here will be 0 plus or minus C. So you can tell that if it's stretched horizontally, the foci are on the horizontal axis, and if it's stretched vertically, the foci are on the vertical axis. So there should be a question that pops up in your mind right now then. How do you know what C is? And the way we find C is we use the Pythagorean theorem, well, almost the Pythagorean theorem. We say C squared is equal to A squared minus B squared. And that's really important because when we get to hyperbolas, we also have foci, and it's C squared equals A squared plus B squared. So the formulas are very, very similar for all this stuff. You got to use this chart I give you here. Last year, I tried to put this all together for circles, parabolas, hyperbolas, and ellipses all on like one sheet of paper for people to understand, and it got too messy. So I think I'm just going to try to use this year and see where it goes. I think they'll be better. Eccentricity is how squished or stretched the ellipse is. So when we have an ellipse, we like to know, what's a measurement that could tell us how squished it really is. What percent maybe of a circle does it represent? And the way that we figure that out is eccentricity is equal to C, whatever the foci distance is, divided by A, the half the major axis. And so that's your last equation. Now I know that this may not be extremely interesting to you, but I want you guys to know this is one of the first real applicable studies in mathematics, because what very large things do we have in our universe that travel in an elliptical fashion? Planets. When the great astronomers were trying to model motion of planets, this was the key and extremely important. If you were to take a math class on astronomy and the motion of planets, you had better be a math major. I'm telling you that the stuff is extremely difficult, but it's very impressive to see what they're able to do. So let's get started. Let's try one. It says, sketch a graph of the following. Find the vertices, foci, eccentricity, and the length of major and minor axes. We can do this. We start off by identifying what the center is. What's the center? We said all these are going to have a center of 0, 0. Good. After it has a center of 0, 0, in order to find the other pieces, I'm going to identify A, B, and C. A is the number that's biggest. I'm sorry, A squared is the biggest number. So what's A squared? 25. So what would A be? 5. 5. Okay, how about B? Dos. Now I have to find C. In order to find C, I use my formula. C squared is equal to A squared, which is 25, minus B squared, which is 4, and I get C squared is equal to 21, or C is equal to approximately, say, 4.5. Square root of 21 is about 4.5. What do you think? Any questions how I got those? We can now sketch all the important parts of the ellipse. So last year I tried to have people rely on charts a little bit more. What I want you to do right now is I want you to always think of this process when you graph really anything. The parabola, the hyperbola, the ellipse. Let's just find out what A, B, and C are, those important parts. And then let's just draw the graph. After we draw the graph, then we'll name everything. Once you have the graph, it's easy to name everything after that. So I'm going to draw my graph. I go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. People were asking for graph paper, and I said, I'm going to draw a good graph. So take that. So I'm going to start by plotting the vertices. How many units is it stretched in the vertical direction? 5 each way. So I go up 5 and I go down 5. How many units is it stretched horizontally? 2. So I go over 2 on each side. And then I draw my ellipse to the best of my ability. Not hard to do. And I'm going to plot my focus points, my foci. It's about 4.5. I'm going to put that one there. Put that one there. The closer the number is to 1, the more squished or stretched it is. The closer it is to 0, the more it looks like a circle. Okay? And so let's now identify all the important characteristics. It says vertices. It says foci. It says major axis, minor axis, and eccentricity. Vertices. Just look at it. What is it? Zero plus or minus 5. It's the endpoints of the furthest direction that it's stretched. So instead of writing, 2 coordinates, you could just write that plus or minus. That's fine. The foci. 0 plus or minus 4.5. It's the longest distance here. 10. Shortest? 4. In order to find eccentricity, I take C divided by A. C is 4.5. A is 5. Divide that, and you get approximately 0.9. So this thing's, pretty stretched out. How do you like that? Wasn't too bad, was it? You're going to be really quick at the second one now that you know how to do the first one. Only what's different about the second one? Yeah. In order to find the important characteristics of an ellipse, it has to be set equal to 1. So I divide everything through by 36. And I'm going to get a new equation. It's of the form x squared over 9 plus y squared over 4 equals 1. Now, my good friend Brooke Hansen, I don't know if you know her, she said something really intelligent at this point. She said, well, Mr. Gens, so if you have the same number underneath x squared and y squared, that would mean it's a circle then. Yeah, exactly. Yep, if you had x squared over 9 plus y squared over 9 equals 1. Look, you could just multiply through by 9 and get x squared plus y squared is equal to 9. Well, that's a circle that's centered at 0, 0 and has a radius of 3. Look, it's stretched 3 in the horizontal direction. It's stretched 3 in the vertical direction. So therefore, it would be a circle. So that's very astute to think of that, and hopefully you guys thought of that as well. You're all very smart. Now we have x squared over 9 plus y squared over 4 equals 1. Is this stretched vertically or horizontally? Horizontally. Why? bigger numbers under x squared. Excellent. So I'm going to identify the center. We set it 0, 0. Now I'll identify A, B, and C. Your new classmate, Haley. She's a nice person. You can come say hi to her at any point you want to. Identify that stretched horizontally. That means that A is the bigger number here, which is 3. B would be 2. How do I figure out C? C squared is equal to, oh boy, 9 minus 4. So C squared is equal to 5. So square root of 5 is what, like 2.2? Something like that. 2.21. Who knows? We'll just make stuff up. All right. So before I actually label what everything is, let's just quick draw the graph. If I just make, 3 tick marks here, that's going to be enough. How many units horizontally? 3 each way. Vertically? Dos. Not too bad. I'm going to plot my foci, 2.2 units. Benny, you got a question? Or is he answering for you? All right, he's smart. Okay, so we need the vertices. We need the foci. We need major axis. We need minor axis. And we need eccentricity. What are the coordinates of the vertices? Plus minus 3, 0. Good. Foci. Plus minus 2.20. Length of the major axis. Minor. For eccentricity, I take C, 2.2, and divide it by A, which is 3. Don't really know. Yeah. Biggest number is 9, right? Square root of 9 is 3. Square root of 4 is 2. So it's stretched 3 units horizontally. Stretched 2 units vertically. So if we look at our original one, or we look at this one right here, stretched 5 units vertically, stretched 2 units horizontally. So, you just, the larger numbers where it's stretched more. So, but it always lines up underneath the X or the Y then. Okay, 2.2 divided by 3 is like 0.73, something like that. Is that, yeah? Okay. So that would be, so this one isn't stretched quite as much as the other one. Value 0.73. Looks more like a circle than the other does. So I have an assignment for you guys. And we do have a lot more work to do with these, okay? What I want you to do is I want you to do problems 1 through 10. The first 4 are just matching, okay? But be ready to go to work tomorrow. We got lots of stuff to cover. Good luck.